we want to talk about what we are all way too familiar with, which is object-oriented programming. And then we want to compare that to a different way of doing things, which is data-oriented programming. And the question is, which one should we choose? So we'll take a little bit of time, talk about OOP, just a little bit, and then we'll talk about where it makes really good sense. We'll talk about another example where that may fall apart, and then see what else we can do in terms of moving forward. So that's exactly what we're going to do. Best time to ask questions is anytime you have a question or a comment, draw my attention, ask your questions, we'll move forward. So what are the pillars of object-oriented programming? We know that there are four important things that come together to make object-oriented programming, right? The first one is abstraction. But if you think of abstraction, abstraction is nothing new in object-oriented programming. Humans have used abstraction forever. There is evidence of people like Plato talking about abstraction. He was talking about comparing a picture of an eggplant to a real eggplant, for example. So essentially, the idea is we use abstraction to comprehend complexity. So by relying on abstraction, we are able to say, I don't need to know all these details. I can abstract it out, and I can then work at that level of abstraction. So we do abstraction in many, many ways, and object-oriented programming is one of the ways in which we create abstraction. The next thing in object-oriented programming is encapsulation. And encapsulation also is not specific to OOP. Encapsulation is where you are hiding the implementation details and you are trying to really separate what you do from how you do it. You can have encapsulation at a function level. You can define a local variable to a function. Your local variable in a function is not visible outside the function. That's encapsulated as well. So you don't need objects to encapsulate. You have inheritance. Inheritance is, I would argue, the weakest link in object-oriented programming. Inheritance allows you to create or build upon one abstraction on another to say that this extends another abstraction. But that also increases tight coupling. Then we have polymorphism. And polymorphism says the method you call is not based on the type of the reference, but on the type of the object at runtime. So this gives you the extensibility in your application by way of this polymorphism. I would argue polymorphism is probably one of the most important aspects of OOP. It gives us extensibility. Take away polymorphism, there's not a whole lot of benefit to the object orientation. So polymorphism is extremely important. So when we program with with the object-oriented paradigm, we tend to leverage polymorphism very extensively. I would say that's the star of the entire paradigm. But of course, the essential here is that in terms of the essence of OOP, I would say polymorphism is the essence of OOP. And of course, we want to leverage object-oriented programming. How do we actually do this? So let's take a look at an example to think about it, if you will. So I have an order processor. Again, it's a small example just to illustrate the problem, right? So we have an order processor. I want to process an order, so I call the process order, and obviously you would have other details for the order. What are you buying? How many quantity you're buying? All the details we don't care about right now. But I want to pay for this order. So what am I saying? I'm going to say order processor and process order, and I'm going to pass a credit card information to it. So I say new credit card, and then I'm passing the details of the credit card, whatever it is, right? The number, the expiration date, blah, blah, blah. I can give you all those details. So the question is, how does the process order function look like? So if you look at the process order function, the process order function takes a credit card, and then it does some work to process the order, and then charges the credit card for an amount of $10, and then does some more work. So that seems logical, isn't it? Now, if the business says that's all we ever want to do, we are done. Nothing more, nothing less, right? Don't go out to creating more complexity than you need. But if the business says, oh, by the way, we want to receive payment, but the payment may come through a credit card. The payment may come through a PayPal or Venmo, or a payment may come through a bank transfer. And in that case, this code is not going to help us. Why? Because it fails on the open-closed principle. And open-closed principle says a modular software must be open for extension but closed for modification, meaning we must be able to work with reasonable change in requirements but without having to modify the code for it. So in this case, the reasonable change in requirement is to be able to accept payments through multiple forms. So how do we make this code more extensible? How do we decouple it? So one way to decouple it is to use the dependency inversion principle. So the dependency inversion principle says that rather than depending on a concrete class, meaning the order processor, depending on the concrete class credit card, it can depend on an abstraction. So what I'm going to do for this is I can go back to this code and say, rather than depending on the credit card, let's go ahead and say this depends on a payment method. And we'll call this as payment method. So we introduced a payment method. And in this case, we're going to say payment method dot, let's say, pay. And we're going to pay using the payment method, right? So we introduced a payment method. So the question is, what is a payment method? So I can then say in this case that I want to introduce an interface called payment method. So where does this payment method interface go? It goes into the payments package. So here is my payment method interface. What does the payment method interface have? It contains a method called pay, and the pay method is going to take an amount in cents that I want to pay. So that's basically the abstraction we created, which is the interface. So now that we have a payment method interface, what I can then do is I can go to the credit card, and in the credit card, I can say this implements the payment method, right? So as a result of implementing that payment method, we can now call this as pay rather than the payment method. But what is the benefit we got out of this? I can go back now and say order processor dot process order, and rather than paying using a payment method of credit card, we could simply say new bank, let's say, transfer, and I can provide the details of the bank transfer in this particular case, much like how we would have provided for the credit card. So as a result, I can now say I have a bank transfer. And what does this bank transfer do? It is actually a class I'm going to create. Where am I creating it? Under the payments, obviously. And that implements the payment method. And I can then say I have the method I'm going to implement right in there. And the method I would like to implement is going to be the payment method, right? The pay method that I want to implement. So we can say, here comes my pay method. I'm going to say, here is the pay, and that's going to be an amount in cents I want to implement in this particular case, and we can do whatever code we want to do for that in here for that pay method, right? So this is going to be the public, let's say, in this case, the pay method. And we can say, whatever it is, we can specify, a pay via, let's say, a bank transfer. So essentially, but what did we achieve by doing this? The idea in this case is I can execute this code, I can pay via bank transfer, or I can pay via a credit card. But what's the beauty of this? In order to have different payment methods, I did not anymore have to change the pay process order or the order processor. So in other words, now the order processor is extensible for accepting payment in different forms as long as those different forms of payment methods conform to the payment method interface. So far, so good? That's basically the essence of OOP, isn't it? So what we are doing with object-oriented programming is we are providing extensibility by way of using polymorphism. So let's park that thought aside. We'll come back to it a little later as we go through it. So what is it that we learned so far, or maybe we reminded ourselves so far? We can say that we can say OOP relies on polymorphism to provide extensibility. So this is essentially what we really strive for when using OOP. We rely on polymorphism, and where did polymorphism come in here, you may ask? Well, polymorphism comes in here in the form of this method. Notice the reference type is payment method, but the method that is called is not based on the type of the reference at compile time, which is payment method, but based on the type of the reference at runtime, which is a credit card type or a bank transfer type or a PayPal type and so on. So as a result, this method call may end up with different destinations depending on what you provide in this particular case. That's where you get the extensibility in your code. So what do we do typically in OOP? Typically what we do in OOP is we build essentially, right? Build a class hierarchy and leverage, if you will, polymorphism, leverage polymorphism in a sense. That's what we do. So leverage polymorphism to gain on extensibility. So this is really what we are after. So we've been using OOP for a very long time. When I was a very young programmer, that was the time when the world was still asking the question, is OOP a good idea or a bad idea? And I remember as a young programmer looking at discussions, OOP sucks, OOP rocks, you should never use OOP, you should use OOP. And then all that quieted down, and then we all got into that bandwagon. Then we quit asking those questions. And unfortunately, we quit thinking after that. And then we started just following it, and that's what we've been doing. And that's okay, right? When it helps us, that's really good. But at some point, we got to ask the question, is something helping us or something is not helping us? Now, one of the things we often do in programming is when we solve a problem using a certain approach, we see that we are using that in multiple places. When you use a solution in multiple places, what do you call that as? When you have seen it in few places around. That's right, that becomes a pattern. Now, beautiful, right? You nailed it. That's what is called a pattern. A pattern is a solution we have seen a few times. Now, that's great when the pattern is useful for us. But you can say, here I use a pattern. That's good. But if you reverse it, I wonder what pattern I can use here is a dangerous question. Because now we are saying, I want to pick a pattern and apply rather than saying, here is my problem, here is a solution that seems to make sense. I wonder what name can I give to it is a nice thing to do. So this is where we got to be a bit careful about things. So let's move on and see what could be a problem. So I want to work with a third-party class. So the example we saw right now was reasonable, right? Did that leave a bad taste for any of us? Or does it feel like it's a good idea? Very reasonable, right? That's like we didn't really say, yeah, that's smelly, right? Seems reasonable for the problem we were solving, so we can agree to it. Let's move forward right now. And I have a sample trade. And the sample trade is saying, I have a trade, but the trade could be a buy or the trade could be a sell. And the trade could be a buy or a sell, but the buy or a sell and the trade come from a third party. So what does that mean? You have your code base. You are writing your own classes, and when you're writing your own classes, you have full control over what you do with those classes. If it's your class, you can go add methods to it. If it's your class, you can modify the methods, change methods, delete methods, whatever you want to do, you have full control over it. But in this case, trade, buy, and sell are third-party classes. So these are not the classes that you have control over. You cannot change them. These are the library of code you receive and you're using them. Much like the classes that you use from JDK, much like classes you use from maybe a parsing library or a Jackson library. Those are the classes you can reach and use, but you cannot say, I'm going to change this class. I'm going to add a method to it. You don't have that ability, right? Capability to do so. But what I need to do in my application is, my business people are telling me, hey, you need to process trade. Now, let's go look at the trade before we go any further. So if you look at the trade itself, the trade is just an interface. That's what it is. But no, did you notice it's a trade.class, not trade.java, right? Why is it trade.class? Because it's third party. I don't have the source code for it, right? So it's trade.class. And what does the trade.class contain? A perform method. Buy is a buy.class also, right? That's a third party right there. And that contains a perform method. Okay, great. But my business people are telling me, you need to perform a trade. The trade, process trade accepts a trade, but I want to call the perform trade. Okay, that was easy. But then they tell me, wait a minute though, before you perform the trade, we have business requirements and you need to audit the trade. And what does the requirement for auditing have? The audit trade says, suppose your business says, if the buy is of a quantity greater than 5,000 or a sell is for more than 10,000, you need to trigger a notification, you need to audit it. We want to check if this is a legal trade, a good intentional trade, or something we need to send people to look into more to see what's going on over here, right? So in this case, the perform is implemented by the trade. Life is easy for me. But guess who is going to implement the audit rules.audit? This is like AOP. I could use aspect-oriented programming, and I can intercept the call to perform, and I can do audit as well. But I can then go and spend the next 2 hours showing you how to do AOP. We didn't gain a whole lot because that's not our focus. So to make it a little simple, I just call this method to say, here's a trigger point, here's a point cut, and let's go audit it. So here is my audit method that takes a trade as an argument. Now, I want to do auditing for a buy and for a sell. I'm kind of wondering, how can I perform an audit for buy? How can I perform an audit for sell? And maybe in the future, there could be yet another type of trade. And I want to follow open-closed principle, meaning if the code requirements change to audit another type of trade, I want to be able to do it without having to change the code. I want to make the code extensible. Does anyone have an idea how I can extend this code in the future without modifying it? Wonder what concept we could use. Any ideas? Yeah, we just looked at an example, right? How do you make code extensible in OOP? Polymorphism, right? So polymorphism becomes the go-to approach we take. But wait a minute. If I want to use polymorphism, if I have to extend from this code, how do I accomplish that? And you said generic. Well, nice idea. But unfortunately, if classes have their own special methods, your generic is going to break because generic cannot work with the abstraction like that unless it conforms to a particular set of methods you expect already. So polymorphism leverages that for you. You can say, oh, I'm polymorphic. I can do special things over here. So if the new class you introduce has other properties, you can take care of it. The catch over here with polymorphism, though, is the following, right? So to make use of polymorphism, I'm going to say, we're not going to audit these things. So I'm going to say, in this case, we got to audit. But in order to audit, I am going to first of all say, hey, here is an idea. I want to call an audit function on something. I'm wondering, what could that thing be? So I'm going to say over here, how about a trade auditor, right? So I create a trade auditor, right? So auditor, and is equal to, and somehow I've got to get myself a trade auditor. And we will see how we can do that in just a minute. We'll come back to that. So once I get a trade auditor, I can say trade auditor dot audit, audit trade, and I can simply pass the trade to audit it, right? So that could be an option. Okay, then I need this trade auditor. How do I get access to this trade auditor? So we can say here is a trade auditor. So we can say auditor. And this trade auditor, and again, we'll come back to that and see how we can create it. So here's my trade auditor. Where am I going to create this trade auditor class, you may ask? So let's just, for our convenience for now, we'll make this a trade auditor class. And I want to then ask it to give me a trade auditor. So that's a class I'm creating. But where do I create this class? We got to create it somewhere, right? So for now, out of laziness, I'm just going to put that in the client itself for a minute. And that's going to be an interface I'm going to create right there. So what does this trade auditor provide for us? We'll ask that question in a minute. So I'm going to say, just for a moment, I'll just say null. I'll come back to that. An audit trade is a method in there that takes the trade as well. So we created an interface like so. Okay, good so far. Then what am I going to do? And just call the audit trade on it. Well, you probably know where I'm going with this, right? I could simply say here, new by trade auditor. And what does the by trade auditor do? The by trade auditor is a class which implements the trade auditor, as you can see. So what am I going to do with this trade auditor? I am going to ask the trade auditor to implement the audit trade method. So what does this do? For our purpose, we would say, auditing. So in this case, pardon me, if, oh, wait a minute, but this is a trade, isn't it? So what should I do in this case? If trade is an instance of by, then we may even leverage the new capability of Java here. If it is a by trade, then what am I going to ask it to do in this particular case? I can then say if by.quantity, right, the get quantity, we can bring in. So by.get quantity is going to be greater than 5,000. Then we are going to say output large by trigger audit. Okay, so far so good. Otherwise, don't do anything. How about, wait a minute, if it is not by, what do? Throw new runtime exception, unexpected, right? Unexpected trade expecting by. So we could do that, right? So that's our by trade audit. Similarly, what we can do is, going back to this, I'm going to just grab this for a minute. We'll come back to this. So I can go back here and say, this is a cell trade audit. So what does a cell trade audit do? The cell trade audit says, I am going to receive a cell, and if it is a cell, I'm going to then ask if the cell's quantity is greater than 10,000, large cell trigger audit, otherwise unexpecting a cell. So we could provide that in here as well. So the next thing here is, we can go back here and say, aha, but we don't know which one of these two it is. So we could say, I called it a buy. What did we call it? We call it a buy, a sell trade audit, and buys trade audit. So we can say in here, a class.forName, and what is the name we are interested in? Well, it's the trade. So trade.getClass.getSimpleName, that is going to be a buy or a sell, plus, again, you can see my memory is as good as the memory of a fly. We called it trade auditor. So we can say trade auditor, and we got the class name. So we're saying, go get me the class for that class, get me the class name. Once you get it, I can get the get declared constructor. We can ask for it. Once I get the declared constructor, I can call a new instance on it and get the instance from there. But if I go this route, what does Java say? Java says, you better handle that exception. So I'm going to say, what do I do with that exception? You can add the add exception to the method, or you can wrap it with a try catch block. That's scary, isn't it? So right there. And you can handle all those exceptions, and I think it's still not happy with me. Let's see. So we got the trade. What are we going to do next after we're getting the trade in this particular case? So we have the try block, and we are asking for the trade. And what is the trade auditor? It gets us the data. We're going to now cast it to a trade auditor, right? So once we do it, we can then say, trade auditor, go ahead and perform the trade for me, please. I can even leave that here, and we can ask it to do the work. So let's see if this is actually going to do the job, right? So we can go back to the main. We can run the code and see what it does. It says, runtime exception class, not found exception by trade auditor. Let me see if we messed up the name. Oh, of course I did. What did I forget to say? What package it belongs to, right? So if you look at it, it's a client. So I can say in here, client dot and a plus. So then we can ask it again to execute it, and we can run the code again, and yay, notice we are running those, and large by trigger audit, that seems to do it. Now, what is the benefit we have so far here? The benefit we have here is, if you were to introduce a new type of trade in the future, what do you have to do if a new type of trade is added in the future? Thank you. Create a new type of trade auditor. You create that class, right? And then, of course, you don't have to change anything else. So that's useful, right? That's extensible. But let's take a look at the code for a minute. When you look at the code, first of all, how do you feel about the audit method? When you look at the audit method, does it look like a friend who invites you with a smile and says, come on in, buddy, nice seeing you. Sit here, let me get you some coffee. Or does it look like somebody who looks at it and says, why are you here? How do you feel? What's your gut feeling when you look at this code? Is it inviting or is it disgusting? Yeah, it feels like, I don't know if I'm comfortable here, right? This is one of the questions I ask my developers. When you look at a piece of code, how do you feel? When you look at a piece of code, does it bring a smile in your face? Or does your face cringe, right? So here's a way to know about software quality. When you go open the source code, have a mirror, right? Look at the code, look at the mirror. Are you smiling, right? Or are you having a different facial expression, right? This could be an AI tool for code quality. The camera is looking at you. You open the source code, and then they kind of look at your face, and you can get a measure, right? Forget about complexity metric tools, right? This can be a nice way to know. And it can say code quality based on the facial expression, right? So that's basically the idea. How do you feel? Do you feel invited? Or do you feel like this is disgusting, right? So, and then, by the way, this code is very useful Don't discard it, right? The reason this code is useful is if your company is interviewing a candidate and you really don't want to hire them, show them this code and say, this is how all your code is. And then you can watch them scream and run out of the building, never ever to come back. And you're like, that's how we do things, right? So no, that's really scary piece of code as well. And yeah, you could say, you could refactor that, Venkat. Yeah, you can. But at the end of the day, you still have to deal with it. Secondly, when you go back to the implementations of this, and when you look at this, how does that look like? Is that looking like very easy to follow? Yeah. Yeah. So why are we not doing a new? Because we cannot do new trade RG because it's an interface. So we need to create either a buy trade auditor or a sell trade auditor. And if you use an if, then what are you going to do? You're going to say if a trade is an instance of buy, then a trade auditor, you can say auditor is equal to new buy trade auditor. And then you're going to say else if a trade is a instance of sell, then this is going to be a trade auditor. You could say auditor is equal to new sell trade auditor. And then what happens? When a new type is introduced, you have to put another else here. This fails open close principle. You couldn't leverage polymorphism. What is a for name? What is it? What does for name do? Is that a factory or not? And you're saying, no. How dare you use what they provided? I will write a factory class. And I will inherit I love this because he says, this is how you create enterprise software, right? So you have your trade factory and sell trade factory and then a buy. So you don't want 3 classes, you want 6 classes. So when you introduce a new class, I was worried you're going to create one more class, you will create 2 classes. I like that idea. Yeah, I mean, you made a stronger point for what I'm saying. So I thank you for that, right? Because that's what we're going to go towards if we're going to continue on that line, isn't it? And if we do, what's going to be the problem in this case? The problem in this case is we are going to now not only create the hierarchy on the other side. When they create the hierarchy, let's list the problems in this code first of all. The first problem is you will have to go create one more of this class, correct? Actually, 2 more of this class if we go that route. So either we're going to create 1 or 2 more classes. What will those classes be? We'll call it, let's say a different type of a trade we want to perform. Yeah? What was that? Squire. I don't know what that is, but yeah, let's do it. Squire trade auditor. And that implements from the trade auditor, right? And that's going to do the audit for that particular type of trade. In a similar way, we'll also create a factory as well. So the one thing is you're going to create a class. What that means is for a hierarchy that is here, you'll have to create a parallel hierarchy. Is that correct? So the first problem here is we create a parallel hierarchy. So that's the first thing. Second, that side has a new type of trade, but you did not create the class just yet. If you did not create that class, but somebody sends you that trade, what will the code do? a runtime exception. Where will that, what exception are you going to get? Class not found exception. And he's saying, dude, if you created the factory I told you, it would have been a better exception. Absolutely, right? So you gain a little bit. Your exception can say, a new class has been introduced, maybe you should go implement it. So a little bit more error handling. Or you could have done that here as well. Rather than just throwing an exception, you could have said, rather than class not found, you could say, hey, this particular class seems to be added new. We're not handling it. So you could handle that either way. That's one negative, right? So the first is when a new class is added, so we can say when a new class is added, we will get a class not found exception since we don't have an auditor for it, right? That's fair. Secondly, each auditor will have to check for the type and throw exception. So essentially, if you look at this code, what do they do? This is saying, if it is this type, I will handle it. Otherwise, I'll throw an exception. That doesn't seem very dry, right? So in order to fix that and make it dry, what will you do? You will elevate this as a default method in the trade auditor. And you will override it here. And you will say, hey, if it is that type, give me the control. And if it is not, you throw the exception. And we will call that something like a template method pattern. So now notice what we are doing. We just called it the template method pattern. I want you to think about something here. The more pattern names we use, it is a sign of more complex code than it should be, maybe. I always am suspicious. So now we are saying, look what we had to do. Now that we did something, let's give it a pattern name for it. Why? Because it feels better, right? Hey, what are you doing? I'm doing this. I'm inheriting this default method. I'm overriding it. Isn't that complex? Dude, it's a template method pattern. Oh, wow, that's awesome, right? We gave a name for it. So that makes us feel a little bit better. But if you really think about it, the whole way we did this, what is this whole thing? What pattern comes to mind? Anybody knows what this pattern is? A command pattern or a visitor pattern, right? So these all have names, pattern names for it as a way of doing things. But in a sense, we don't get a compilation error. Would you like a compilation error or a runtime error? If you have a choice, which one do you like? Compilation error, right? Because when you compile the code, it says, stop. Hi, that's great. I don't have to know about this at runtime. Well, compilation error happens on your machine. Where does the runtime error happen? He's like production. How do you say you don't do testing without saying you don't do testing? I love it. Awesome, right? Production problem. Why? Because failing in testing is for wimps. We fail in production, right? Absolutely. Why start a small fire when it can burn the whole city, right? Absolutely. I love it. So this postpones it to a runtime. I would rather have a compile time error, right? That's much better. And again, like I said, this is, you're building a parallel hierarchy. That looks like a bloated code, isn't it? Now, you have this code, and your poor business analyst walks in and says, hey, we need to do this processing. I'm just curious, how are we handling it? And you tell your business analyst, tell you what, let me show you the code. And how does your another mirror, right? Give this to the business analyst. Keep looking at the mirror as I show the code, right? Is the code communicative, or the code hides the details of what we are doing, right? So when you look at this hierarchy, you're trying to extract from this hierarchy what you're really trying to do. There is an impedance mismatch in this case, because what you want to do is to process these different trade. But what you're doing is presenting a hierarchy of objects. And from that, you need to extrapolate and say, that's what we're doing. And they're saying, what are we doing for buy? Aha, let me bring the buy trade class for you. What are we doing for sell? That's another class I need to bring. We're switching between these classes rather than giving a view directly in front of them. I'm not saying never do this, but everything is a trade-off. My recommendation is this. I'm almost never good at saying, do it this way, don't do it that way. My recommendation is, when you feel like there are a couple of options in front of you, take a deep breath and prototype it. And when you prototype it, in front of you, you have two solutions. I'll tell you why prototyping is so important. I'll give you an example of this. This is a non-programming example. Nevertheless, I think it helps us to understand it. So the non-programming example, when we were building our house, in the bathroom, we wanted to have a mirror. And my son, he's a designer. He's got some really strong opinions, but he also knows that I have strong opinions as well. So he came to me and said, what kind of mirror you want here? And I said, well, it's a square wall. I'm going to put a square mirror here. And he is listening to me. He knows me very well, and he kind of listens to me. And then after a while, he says, Dad, you've given your opinion. And then he says, I want you to calm down. I don't want you to get excited. I'm going to show you some options you will dislike. But I just want you to entertain this thought. You can always say no. I'm like, okay, I will wait until a few minutes before I start screaming. And then he says, and he brings a little application, which is a little VR. And then he says, here is the wall. And then he drags and drops a mirror, a rectangle mirror. I'm like, yeah, that's what I was talking about. Then he drops a square mirror. I'm like, yeah, okay. And then he drops a circular mirror. If they asked me, would you put a circle mirror? I said, heck no. So he puts a circle mirror. I'm like, And then he's like, what do you think? I'm like, I'm not sure about this. And they said, okay, hang on, let's do something else. And they run to the store and they literally bought a circular mirror. And they put it there, holding it, and said, what do you think? I'm like, oh my gosh, this is beautiful. And I'm like, that's what I want. And I completely slipped from saying heck no to that's exactly what I want. And then we called the builder and said, we know exactly what we want a circular mirror. And the point is, I would have been adamant about it had I not seen a prototype. So to me, one of the best ways to convince yourself and your team is to prototype. So don't hesitate. I'm not saying this is good, this is bad. I'm saying do both and look at them side by side and then drop your biases and say which one is better, right? So let's see what we can do here. So let's go back to this code. Let's leave those aside, Let's not waste our time dealing with that for now. Let's get rid of all of that. Pretend we never wrote that. Now what do I want to do? I come back into this code and say, hey, here's an idea for you. I want to do some operation in here. So I'm going to say a var result is equal to, and I'm going to say switch. So this is for pattern matching. On the trade, I'm going to bring that in. And then I'm going to output in here, and we'll say trade dot get class will provide that plus, and again, you can beautify this and all that, but I'll just put the result here just for now. So what is the result going to be? I'm going to simply say in here, a case by, and I'm going to say, auditing, let's say by. We'll just leave it at that for now, right? Similarly, I'm going to say over here, a cell and a cell, and I'm going to simply say auditing cell. But I can go a step further than this as well. I can say case by, we can say by when buy dot quantity, so we can say buy dot quantity is greater than 5,000, I can say auditing a large buy, and again, whatever details, right, you can put it in there. Similarly, I can say, in this case, case sell right here, and we can say sell, this is going to be a sell, and what do I want to say? Where the sell dot quantity is greater, auditing large sell, and you can put more details on it. Then you can say default, and what am I going to say for the default? Unexpected trade. So let's start with that thought, and we'll see where it takes us. So we'll come back to this and talk more about it. So I go back now to the trade, to the sample trade. Let's run this and see what it does. The output is exactly the same as before, right? Yeah, well, except for the messages I changed. So the behavior is the same. But when you look at this code, now remember, we don't have the factory. We don't have the auditor classes hierarchy. So here's the class hierarchy they gave you. Did we parallel the class hierarchy right now? No, right? We don't have the class parallel hierarchy. We just wrote this pattern matching. And we said, if it's a buy, do this, sell, we do this. Your business analyst walks in and says, hey, how are we handling it? There you go. What do you think of that? You can call other methods from here, which are good names. Nothing says everything has to be here. But you are able to say, so the code is very much in correspondence to the business expectations. Which one of these to have higher cognitive load? The other one does, right? This has less cognitive load. And if, in this particular case, we'll go a little further. If we introduce a new type of trade, right now, as we wrote it, will we get a compilation error? No. We will get a runtime error, right? Or unexpected trade as a message. That's not good yet. We didn't solve all the problems. However, we can do something a little different. We can go back here and say, hey, public sealed interface trade permits buy and sell. So we told it, I am going to not use a class, but I'm going to interface. I'm going to use a sealed interface. So what does sealed mean? Sealed says you are allowed to only have a buy and a sell as things that inherit from trade. You cannot have anything more than that. Now that we added that sealed in there, if I look at the sell, it implements trade, buy implements trade, but I'm going to make these two as final class and make this as a final class in this case. So by making them a final class, what did we gain? If I go back over here into this code, you can see it. Notice the default. It says default branch is unnecessary. Did you see that? Why is it unnecessary? Because it's sealed. You don't have to write it. So the IDE says, get rid of it. You don't need it. Now, the third party says, we're going to introduce a new trade. So they introduce a new trade, and they tell the trade permits buy, sell, and the new trade. Well, we get a compilation error. That's right. So you get an immediate compilation error saying, hey, you're not handling this new trade. So you can immediately go fix it, isn't it? How so? If I go back here to this code right there, and I'm going to say in here, I'm going to go ahead and add this. So let's go to the work area, and I'm going to go to the sample here that we have. Pardon me. I'm going to go here to the third party. After all, that's third party, right? So third party, and in the third party, I'm going to go to trade right there, and I'm going to then in the trade, I'm going to say buy.java to new trade.java. So what does the new trade.java do? The new trade Java says this is a new trade, and the new trade says I'm going to have performing a new trade. So we have a new class in there. So notice what's going to happen now in this particular case. It is telling us, okay, I made a mistake on that. Let's go ahead and fix it. So this is going to be the new trade.java. So here's the new trade. And the new trade basically says I'm going to provide the perform method and it implements a trade. But remember what we need to do. Go back here and say new trade, right? So bring that in. Now when I go here, what does it say? It says switch expression does not cover all possible input values, right? It's giving me an error, compilation error that you mentioned you will get. So now I have to say, I got to extend this. So I'm going to say, what do I do? I'll go to the business people and say, excuse me, what should I do for the new trade? I'm not going to just throw some code in there and they tell me what to do and I'm going to follow their instruction right now. So I say case over here, new trade, and the new trade, I'm going to specify whatever they tell me to do. So we can handle that. So far, so good? Now, almost there, but we can do one more thing in here. We can go to the buy and we can say, look, that's quite smelly, isn't it? So we can make this a record, and now we introduce sealed, we bring in record, and we say string ticker and int quantity, and I can get rid of that altogether. You can still leave your perform method, nothing wrong with that. So that's my buy, as you can see. Likewise, I'm going to implement I'm going to get rid of the new trade, right? We don't want that. So let's get rid of the new trade, and which means we get rid of this from here. So let's go back here. So now what am I going to do here? In this case, I go back to this and I say, hey, this is, that's gone. So this is the cell, and we say this is a record. Well, records are final already. So string ticker int quantity, I can remove this part, and this becomes the ticker, and this becomes the quantity. So we have those two in place. Now I can go back here, and it's complaining. What's the problem in this case, you may wonder, right? Oh, pardon me. I need to get rid of the new trade from here as well. That's gone. So back here, I'm going to say buy, but I don't care about the buy. So I can simply remove that and say, this is a quantity I'm interested in. So when quantity is greater than, similarly, here is a cell, and I don't care about the ticker in this particular case. So I can say var quantity, and when the quantity is, I can use the 2 to bring that in. And in this case, I can keep this as a buy in a cell. So we are able to leverage the destructuring here as well because it's a record. So again, we want to make sure this code is actually working. So let's go back to this one in the sample trade, run the code and see if that works and come back here. So that code became a lot more concise thanks to destructuring of records. We're able to pull the quantity out and verify the code is more concise. Now, remember, always trade-off. When you talk about solutions, you should not overly praise a solution. You need to be objective. And always there are pluses and there are minuses. We talked about the pluses of the OOP solution. We talked about the minuses of it as well. It's only fair to do the same thing here. What are the pluses and the minuses? Let's talk about that. So for the data-oriented programming, the plus is it is simple, easy to understand, easy to communicate, right? That's a plus. Compilation, error, if new types are added in the third-party relevant area. But what is the negative, right? Negative, we need to also identify that. The negative is, in this case, we have to change the pattern matching code when we get a new type violates open-close principle. But it is more dry than the other solution and far less complex. So less on OCP, more on simplicity and dry. So if you think about it, that's a trade-off, isn't it? And now you're asking, which way should we go? Okay, it's a violation of OCP. I'll agree to it. But when a new type is added, how expensive it is to make that change is the question you want to ask. Typically, if it's more expensive to make the change, you want to favor more extensibility. If it's less expensive to make the change, if the audience is messing up, testing, are you able to hear me? Good, okay. So it's clear they are favoring OOP. They don't want you to know about data-oriented programming. So essentially, in this case, the idea here is you are going to make the change to the code. However, the change is relatively minor, isn't it? So you ask the question, is this a change? Yes. We're violating the principle, yes. But how does it affect us? Is it a huge problem? Relatively small. This is one of the things we need to keep in mind, because when you are looking at something as extreme, you might say, ooh, shouldn't do it. But then what's the real cost of change? So the entire idea here is that by relying on some of these, the code is more concise as well. So the question is, where are we? So I would probably summarize this as OOP relies on polymorphism to provide extensibility. But you can also say in this case that data-oriented programming relies on, you could say, right, pattern matching to provide simplicity. It's easy, it's simple, it's clear, and conciseness, right? So simplicity and conciseness. And it's a trade-off. So which one should you choose? And the answer is both. You should choose both. Choose OOP when you are in control of the hierarchy. Choose data-oriented programming when you're not in control of the hierarchy, but your goal is to process these different data. So you can write less code, easier to understand, easier to maintain. So it's not like you choose one or the other. You choose either one of them, but based on the situation you are in. And I would say, which one should you choose? My answer is choose simplicity. Choose whichever is simple. To me, OOP is simple on the order processing example. But data-oriented programming is simple for me in the trade example. So choose whichever is simple, whichever is less complex, whichever gives you more capability. And the beauty is now, we got these tools on our hand, and we get to decide which of those tools we really want to use. Hope that was useful. Thank you.